Hello viewers, I am Kausalya. Today we are going to solve problem number 3 under the topic Nyquist plot. The problem is for a feedback control system, it is given by this transfer function, find the gain margin and stability from the Nyquist plot. So the first step is we are going to calculate number of poles lying on the right half of S plane. So as we all know, the denominator term are known as poles and the numerator term are known as zeros. So here we are having two denominator terms. See, one is a simple function and another one is a quadratic equation. So now we are going to solve these two expressions and finally we are going to tell whether any poles are lying on the right half of S plane. Right. So by solving, you see here S plus 4 is equal to 0, therefore S equal to minus 4. Since we are having a quadratic equation, we are using the basic formula to find the roots. You see here the maximum power is 2, right? So here we will be having two roots for this equation. So the basic formula is minus b plus or minus root of b square minus 4ac by 2a. So from this expression, the value of a is 1, b is 2 and c is 2 again. So just by substituting the values, so here we are substituting the values. So in the place of B 2, in the place of C 2 and again in the place of A 1. So by substituting and solving, you see finally we are getting the value as minus 1 plus or minus j. So the value of one root is minus 1 plus j and the another root is minus 1 minus j. Right. So let me write that one, minus 1 plus j and minus 1 minus j. Right. Now this is our S plane, right? So this is your real axis and this is your imaginary axis. Now we are going to mark the poles here. So what is the value of this first pole? It is minus 4. So here it is marked minus 4. And the next thing is minus 1 plus j. So here lies my minus 1 and here is my plus 1j. So minus 1 plus 1j here and again minus 1, here it will be minus 1j here. So just from the S plane, you tell me whether any poles are lying on the right half of the S plane here? No, because we have three poles and all the three poles are lying on the left half of S plane, right? So poles lying on the right half of S plane is 0, that is no poles are lying on the right half of the S plane. Second step is n equal to p minus z. N is number of encirclement, p is number of poles lying on the right half of S plane and z is number of zeros lying on the right half of S plane. So just now we saw, right, no poles are lying on the right half of S plane and from the problem there are no zeros. Okay, zeros are not at all given, so it is again 0. So finally the value of encirclement is 0. That is Nyquist plot should not encircle this minus 1 point. Right. Next one is step 3, drawing a rough Nyquist plot. So here this is our rough Nyquist plot, right? So when you look carefully, there is a difference between our previous problem and this problem. What is the difference is, in the previous problem there is a pole lying at origin, right? But whereas here there are no poles lying at origin. You see, this is our problem, right? So this is our rough Nyquist plot. So you see, there is in the previous problems there will be a small bulge here, but here since there are no poles lying at origin, here it is directly covered like this, right? So here now we are going to divide this plot into different sections. So this is your section 1 and this is your section 2 and finally this is your section 3, right? So then the next thing is finding expression for phase angle and magnitude. So this is our given problem. Replace S by j omega. So once this is done, we are simplifying this equation. You see, this j omega plus 4 here as such. So j omega whole square is, j square is minus 1 and omega to the power square is omega square. So here it is minus omega square. The next step is again we are combining the real terms together and imaginary terms together. So here in this case the real terms are minus omega square and plus 2, right? So when you combine here we are having as 2 minus omega square and this plus j 2 omega. Now we are going to write the expression for magnitude as well as phase angle. So how to write the expression for magnitude? You have to take square root and you have to square the elements inside. Okay, both should be done. So square root of omega square and 4 square. And here again square root of 2 minus omega square whole square plus 2 omega whole square, which is nothing but 4 omega square, right? And the next one is expression for phase angle. So how to write? Again you see from this basic equation, right? So here both the terms are in denominator. When you move this denominator terms to the numerator, we have to insert a minus. So here minus tan inverse of imaginary coefficient is omega and the real term coefficient is 4. So tan inverse of omega by 4 and again minus tan inverse of, here in this expression imaginary coefficient is 2 omega and the real term is 2 minus omega square. So here tan inverse of 2 omega by 2 minus omega square, right? And now we are going to analyze each and every section. So just consider our section 1. So in this section 1, so this is our section 1, right? So its starting point is plus j infinity and it ends at 0. So here substitute the values. At starting point omega is infinity and at ending point omega is 0, right? Just substitute the values in these expressions again. So when you substitute omega as infinity, here what happens? Anything divided by infinity is 0. So here the magnitude is 0. And again when you substitute infinity, here tan inverse of infinity will give you minus 90 degree. Right, and again here you see I am having an omega square term, right? So a single omega contributes 90 degree. What about omega square? This contributes minus, that is this contributes an angle of 180 degree. So here this minus I had written here and 180 degree. So what happens? Minus 90 minus 180 gives minus 270 degree. Right, so here I had written that minus 270 degree. And the next thing is now we are going to substitute the value of omega as 0. So here when you substitute the value of omega as 0, what happens? You see this 40 again divided by omega is 0 here. So square root of 4 square is nothing but 4, right? And here again this omega becomes 0, right? So what happens? 2 square and again when you take square root it will become 2, right? 4 into 2 and this omega square term will become 0. So when you solve what happens? 4 2s are 8, right? So 8 5s are 40. There will be having an answer as 5. So here the magnitude is 5 here. Again when you substitute omega as 0 for a phase angle, tan inverse of 0 is 0 and again this term is also 0. So the angle is 0 degree, right? So to find the degrees of rotation, we have to subtract this angle. Okay, you have to subtract these two angles. So 0 minus of 270 degree. So minus into minus will become plus, right? So here we are having 270 degree. So this plus sign indicates that the plot should be rotated anti-clockwise, right? So now we are going to draw section 1. So you have to start from 0 degrees, right? When you move anti-clockwise, the angles are positive and when you move clockwise, the angles are negative. So here 0 degree. So here when you move anti-clockwise, it is plus 90, plus 180, plus 270. And when you move clockwise, minus 90, minus 180, minus 270, right? Now we are going to draw the plot. So what is the starting point? It is 0, minus 270 degree. So first find out where is minus 270 degree line. So this is your minus 270 degree line and this is your origin 0, right? It starts from here and it is rotated 270 degree anti-clockwise. So 270 degree means it has to cover 3 quadrants, right? So here it starts here and it covers 1 quadrant and it covers 2nd quadrant and finally it covers 3rd quadrant. Totally it has to cover 3 quadrants, right? It starts here, it travels in anti-clockwise direction, it covers 90 degree here, another 90 degree and another 90 degree here. So totally 270 degrees and the direction is anti-clockwise. So just mark over it, right? And again, now we are moving to our section 2. So where is our section 2? So this is our section 2. Right. So when you look carefully, section 2 is nothing but it is the mirror image of section 1. Do you agree? You see, it starts from infinity and ends at 0. Here it starts at 0 and ends at somewhere infinity. They both resemble each other. They are mirror image of each other. So we can simply write section 2 is nothing but it is mirror image of section 1. Right. And section 3, as we all know, it starts at infinity and again it ends at infinity. So it is not needed. Now we are going to find the omega pz and q. That is, q is nothing but intersection point on the negative real axis. So this is our given problem. We had replaced just by j omega, right? And the next step is rationalizing. So rationalizing is nothing but to this expression we are multiplying and dividing by the numbers with opposite signs. That's it. So here you see I am having 4 plus j omega. So here 4 minus j omega. So here 2 minus omega square plus j2 omega. So here 2 minus omega square minus j2 omega. Right. So here we are multiplying and dividing by the same term, so that the original value won't get altered. Right. This is known as rationalizing. And the next step is we are going to multiply. So as usual, you see this 4 minus j omega is multiplied with this 2 minus omega square. See, right, minus, and again 4 minus j omega is multiplied by this 2j omega. So it is written here. And when you look at the denominator terms, you see here we are having 4 plus j omega and here 4 minus j omega. So this is of the format a plus b and this is of the format a minus b. So what is the formula? It is a square minus b square. So a square is nothing but 4 square, which is 16, and j omega whole square will give you minus omega square, but here we are having another minus. So minus into minus will become plus. So here I am having plus omega square. And similarly, this is a plus b term and this is a minus b term. When you use the formulas, we are getting values like this. Right. These are simple basic maths. Then the next thing is we are going to multiply. So I am going to multiply these two terms and I am having an expression like this. Similarly, I am going to multiply these two terms and I am having an expression like this. Right. And the next thing is, again, these are just simplifying the expression. That's it. So here now you see 8 minus j2 omega. Here everything, I am moving this negative sign inside. So what happens? This becomes, both these terms become minus. So here I had written that. Now we are going to combine the terms. Okay, combining the terms as real and imaginary. So here when you look at the real terms, here you are having 8 minus 4 omega square and minus 2 omega square. Since both are with the same omega square, right? So we can add or subtract. Here both are having the same sign. So here we are adding. So minus 4 omega square and minus 2 omega square can be written as minus 6 omega square, and here this 8 is written as such. Next step is we are combining the imaginary terms. So what are all the imaginary terms here? You see j2 minus j2 omega plus j omega cube and minus j8 omega. Right. So here in this term again we are combining. See, we are having two j terms. So here minus 2 minus 8 gives you minus 10 omega, and here this j omega cube as such. Right. And the next step is Here I am taking this j commonly outside and the remaining terms are as such, right? So in this case, to find the omega pz, we have to equate the imaginary term to 0. So here what is the coefficient of imaginary term? It is omega cube minus 10 omega divided by this denominator, because this denominator is common for both the real term as well as the imaginary term, right? So here I had equated this imaginary term to 0. So when you move this denominator part to the right hand side, what happens? 0 multiplied by this term becomes again 0. And when you simplify, when you move omega cube minus 10 omega equal to 0, and when you move this minus 10 omega to the right hand side, this becomes plus 10 omega. So this omega square and omega will cancel each other, and finally the value of omega square is 10. So the value of omega is square root of 10, right? Now we are going to substitute the value of this omega pc in the real term. So what is the real term here? So this part is our real term, right? This thing. This will be our real term. So here this is our real term. Now I am going to substitute the value of omega as square root of 10. Or in other words, you can substitute the value of omega square as 10, right? Both are same. So since we are having more omega square terms, you can substitute the value of omega square as 10. So when you substitute the values here, after simplifying, here we are having the value of q as minus 0.769. Q is nothing but the intersection point on the negative real axis, right? And the step 6 is, now we are going to draw the original Nyquist plot. So the original Nyquist plot can be drawn by combining section 1, section 2 and section 3. So this is our section 1 drawing, right? Just look at this carefully. Again I am going to draw the same thing for the final Nyquist plot. So this is our original Nyquist plot. As usual, mark down the angles. Angles in anti-clockwise are positive and angles in clockwise are negative. So this is our diagram for our section 1, right? It starts here, it travels here and it ends at here, right? And as we all know, section 2 is the mirror image of section 1. So for section 2, just we are going to draw the mirror image of section 1. You see, this is our section 1. So this is our section 2, right? And section 3, no analysis is done. So finally, this is our final Nyquist plot. You see, the direction of rotation is anti-clockwise. So you have to mark the arrow marks accordingly. It should be in anti-clockwise, right? And here we had find out the value of q. Q is nothing but minus 0.769. So here, this is the value. Okay, this intersection point on this negative real axis is minus 0.769, right? Now tell me whether the point minus 1 is lying inside this area or it is lying outside, because this point value is 0.7, right? So only the values which are lesser than 0.7 will be lying here. Do you agree? For example, if it is 0, here it is 0 only, right? 0. Here what happens? 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7. So 0.8, 0.9 and here we will be having our minus 1, right? So here the point minus 1 lies outside, right? Now go and check with our step number 2. So in step number 2 again, the value of n is, that is number of encirclement around minus 1 should be 0. You see, Nyquist plot should not encircle this minus 1 point. Here in this Nyquist plot also the same thing is done, right? This point minus 1 is not encircled. So the number of encirclement around this minus 1 is 0, right? So here from the plot the value of n is 0. So this matches with step number 2, right? So the system is said to be stable. Then the next thing is we are asked to find the gain margin. So what is the formula to find the gain margin? It is nothing but 1 divided by mod of that is 0q, that is the length. So here you see this is our OQ, right? So what is the length of this OQ? It is nothing but minus, that is 0.769. Since we are here, we are considering only the magnitude, no need to insert the minus sign. Okay, we can neglect it. So 1 divided by 0.769, which is nothing but 1.3. So gain margin in, suppose if you are finding gain margin in dB, it is nothing but you have to take 20 log of this value. So 20 log of this 1.3 is nothing but plus 2.27 dB, right? Thus the problem is solved here. Hope you people understand well. If you have any doubt, let me know in the comment section. Thank you.